Continuous delivery works fantastically well. It's a holistic practice, but everybody's got to start somewhere. So what does a simple case look like? Where do you begin with continuous delivery? In this episode, I'm going to describe what I think are the basics of a deployment pipeline and how to begin with that. Deployment pipelines are central to the idea of the technical practices of continuous delivery, and they're an enabling tool to allow us to develop some of the other practices too. They act to organise our work so that it is repeatable and reliable, and they provide a focus for our automation that makes it more controllable. Deployment pipelines offer a fantastic experimental platform for us to test our ideas on, and we can then make changes to our systems more safely and with more confidence. They are also widely misunderstood. Hi, I'm Dave Farley of Continuous Delivery. Welcome to my channel. If you haven't already, please hit subscribe, and if you like the video at the end, please hit like. Most people and most software vendors assume that when we talk about deployment pipelines, what we're talking about is some kind of automated workflow for build, test and deploy processes. I've often seen people demonstrate their software by saying, here's a build pipeline, and here's a test pipeline, and here's a deployment pipeline. And that's wrong. That's mistaking what our intention was when Jez and I wrote our continuous delivery book and introduced the idea to deployment pipelines. That's not what we had in mind. The deployment pipeline is probably a somewhat confusing term, and if I'm honest, that's my fault. I coined the phrase deployment pipeline, and I did that for some specific reasons, but we'll go into that later. For me, a pipeline is a simple idea. It goes from commit to releasable outcome. That's it. If whatever it takes for you to achieve a releasable outcome is within the scope of a deployment pipeline. If the stuff that comes out of the pipeline at the end is not releasable, then you don't really have a deployment pipeline. You might have something else, that's useful, but it's not really a deployment pipeline. If you need to do more testing at the end, if you need to integrate with other things at the end of the deployment pipeline, if you need to do some kind of sign-off or validation post-pipeline, what you have is not a deployment pipeline. From commit to releasable outcome, and we include everything that constitutes releasability within the scope of the pipeline. The whole idea of the deployment pipeline is that it's the place where you decide if your software is releasable or not. That's its job. If your software needs performance testing to decide whether it's ready for release, then performance testing is within the scope of the deployment pipeline. If it needs some kind of sign-off, some regulatory approval or whatever, that's within the scope of the deployment pipeline. If it needs to be secure, then validating the security of your systems and your software is within the scope of the deployment pipeline. This deployment pipeline is a useful idea. By approaching it in this way, going from commit to releasable outcome, it gives us a valuable tool, and it allows us to understand that whatever it is that constitutes the releasability of our software, we've got to figure out a way to put that and organise that within our deployment pipeline. This matters because using the pipeline in this way gives you this organising principle that can discipline our approach and structure our approach to software development in some fairly important and useful ways. If you'd like to learn more about how to ensure that your software is always in a releasable state, my continuous delivery course, Better Software Faster, is on sale now. Details about the course and how to get 2 free preview lessons are in the description below. The next thing to think about is that if we're going to do this, we want our deployment pipelines to be efficient. What we're trying to achieve is that we're trying to go from commit to releasable outcome multiple times a day. And that really starts us thinking hard now about how we can think about optimizing that process. And all of those different kind of validations and evaluations that now by definition fit within the scope of our pipeline. I recommend on the whole that you should try and achieve a full cycle through your deployment pipeline in under an hour. That gives you a lot of flexibility, and it gives you the opportunity, if you inadvertently introduce an error into your pipeline, of fixing that problem within the same working day. It gives you a few shots at trying to correct any mistakes if you work that way. If you go for longer than an hour, your ability to stay on top of failures is degraded. That may sound close to impossible for some organisations, but organisations are able to do this with complex, sophisticated, often very large software systems. So if you apply your minds to it and your ingenuity to it, you can find ways of achieving this kind of outcome, challenging though it may be. So what does this look like for a simple case? How do you begin with getting this kind of thing established? A good place to start in describing that is probably to describe what I mean by a simple case. So let's imagine we're going to create some software. It's going to be something new, starting from scratch. We've got a blank sheet of paper and we're about to start a new project. We're going to keep all of the code in a single repository. That simplifies things. It means we don't have dependency management problems. We're going to deploy everything together in one single step at the point at which we decide to deploy anything. There are no significant performance or security or compliance demand that demand of us different sorts of evaluations beyond the basic. And there's going to be no data migration. That's in part of this. That's part of this project that we can, as far as we can foresee. I usually draw this diagram to represent deployment pipelines, and this is based on the deployment pipeline that we built when we were building a fairly sophisticated, a very sophisticated financial exchange. And this was pretty complete in terms of the evaluation in the context of that exchange. But this is more complicated than we need for this simple case. So we can do away with some of these stages in the deployment pipeline. When I think of a minimal deployment pipeline, I think of this. We begin with developers committing a change. They're going to commit that change to some version controlled system. Now, if we want traceability, we can imagine hooking up our story management system, Jira or something like that, to our version control system so we can tell the story. And that sort of hooks up the information and we can track what's going on. Once we've made a commit, what we're looking for is very fast feedback. And so we're then going to have the commit stage, which is going to give us fast feedback. I talked about getting feedback in under an hour for the whole pipeline. For this stage, we're working even harder. We're going to try and get feedback in under 5 minutes. This is usually best created with fine-grained, test-driven development style unit tests as the bulk of the evaluations that are carried out at this stage. And success is measured by us creating a deployable release candidate, a deployable unit of software that, if this release candidate is successful in its traversal of the pipeline, will end up being the bits and bytes that we deploy into production. We're going to do whatever it takes in the commit stage to give us this fast, high-quality feedback. So we're looking for feedback in under 5 minutes, and we're looking to establish a fairly high level of confidence. I generally advise about 80% level of confidence that if all of these tests pass, any other evaluations that we do are going to also pass. And that's important, and I'll come back to explain why a little later. Now, this kind of evaluation is focused on the development. These are the tools of developing high-quality software, and they're kind of inward-focused to some extent, and they're the tools of development teams. The commit stage is going to answer the question, does this software do what I, as a developer, believe this software should be doing? And that's great, but it's not quite enough. At the conclusion of the commit stage, we're going to generate this releasable thing, the deployable units of software, jar files, DLLs, executables, Docker images, or whatever your deployable unit of software is, you generate that at the conclusion of a successful commit stage. And now we want to evaluate it further. Looking at it only from the point of view of the development team is not enough. So we'd like to now evaluate our software from the perspective of external users of the system. So we're going to want to carry out some acceptance tests. I have a few videos that talk about acceptance test processes, so check those out if you're interested in this. But primarily, acceptance testing are concentrating on what the system should do from the perspective of an external user of the system, tested in lifelike scenarios in a production-like test environment. We want to deploy our release candidate, our deployable unit of software, into a production-like test environment, evaluate it in lifelike circumstances, and get a picture of whether it actually does something useful from a user's point of view. If all that succeeds, there's nothing more to do. We're ready to release. We've got confidence from the technical quality of our work. We've got confidence that it fulfills the specifications, the requirements that we were intending it to, and now we can push that change out into production. Whether that's a manual push or whether that's an automated push is a kind of business decision. That's it. Those are the components of my minimal deployment pipeline. So we need version control, we need some kind of build management and test management systems for the commit stage. We need an artifact repository to store the binary components and version control those that we intend to deploy into production. And we need an acceptance test stage that gives a simulation of our production environment in which we can evaluate things, and finally a production environment. That may sound like quite a lot of stuff to evaluate our software, but I think that's probably the minimal case. So why pipeline? Why did we call it a pipeline? Well, the process that I've just described to you is a form of pipeline, but probably not the form of pipeline that you're thinking of. I confess that I'm a nerdy person. I'm a nerd. And when I first thought about this process and what it meant, it struck me that what this most clearly reminded me of was instruction pipelining in Intel processors. An Intel processor, from the 486 processor onwards, an Intel processor did a branch prediction algorithm. What happens is that when you get to a branch in an Intel processor, it will spawn off two different threads of execution, and it will evaluate if the branch is true, if the condition is true, and if the condition is, three threads of execution. It will spawn off a thread for the condition, a thread for if the condition is true, and a thread for if the condition is false. At the point at which the condition finishes evaluating, you can dump the thread of execution that was wrong and keep the results of the other one. So you've made progress in parallel. You've managed to evaluate the condition and the outcome in parallel. Now, a deployment pipeline does exactly the same thing. As a developer, I commit a change. I wait for that change for 5 minutes to see whether it passes the commit stage. If it does, I move on and I start working on something new. Meanwhile, the slower, more expensive, more time-consuming evaluations from the perspective of a user where I deploy it into a production-like test environment can be going on in parallel with me doing new, useful work. If all of the tests pass, I've won, and I've done new work alongside the conclusion of the evaluation of my last piece of work. So it's a branch prediction algorithm. It's pipelining. And that's why I called it a deployment pipeline. It might be a dumb reason, but it is my reason. The other aspect that's important from a point of view of a pipeline, it's not about proving that your software is good. Rather, the reverse. Tests are most valuable when they fail. They're sending you the strongest signal when they fail. So the deployment pipeline is essentially a falsification mechanism. If a single test fails, we should not permit the software to be released into production. That too is one of those ideas that's a little bit more slippery than it sounds. It means that we've got to be very, very strong in our ability to create tests that are deterministic and durable and repeatable and give us a clear signal when they fail. But that's all of these things are kind of foundational ideas in kind of creating effective deployment pipelines. The last thing to think about in these circumstances is the objective of a deployment pipeline is for it to be the only route to production. All changes destined for production flow through the deployment pipeline. It gives us an opportunity to test all changes. It gives us an opportunity to trace and audit all changes too. So where do you start in building one of these things? Well, I recommend that you start with the idea of a walking skeleton. If you haven't come across that idea, you can imagine your software system, your whole software system as you envisage it, as some kind of complete entity. What you want to begin with is create the actual bare bones, the walking skeleton, something that's representative of the whole thing, but just kind of a sketch of it really, just the bare minimum that could represent the structure of the whole thing. Choose a simple idea that kind of captures the essence of your system. Keep it simple, but try and pick an idea that touches on the major architectural pieces, the bare bones of your system. If your system has a database, some logic and a web UI, try and pick a case, a story that includes each of those things as your first starting point. Try and create this thin sliver of behavior that kind of is representative of the structure of your system in some manner. Pick that as your starting point and then implement that as you intend to implement every other story in future with commit tests, acceptance tests, building deployable things, building the deployment system, and so on and so on and so on. Use it as a tool to create your deployment pipeline. Do the work to create your pipeline as the story demands that piece of work from you. So initially, in order to start work on making the changes, if you're adopting the practice of continuous delivery, you need continuous integration. The commit stage is a fantastic place to get to establish that. So you start off by creating your commit stage so that you can automate the builds and run some tests and collect the results of those tests. Pick the CI system that you're going to use, Travis CI, Semaphore, Circle CI, Jenkins, TeamCity, Bamboo, whichever you choose, and start off by getting that up and running and then using it as a tool to start developing this first story. The commit stage, if you are then thinking about creating a deployable outcome, a deployable unit of software, starts you thinking about the packaging that you need and the way in which you're going to organize the output of your build if all of the tests are successful. And that kind of leads you into building something that allows you to version control those outputs, and that's your artifact repository. Acceptance testing, writing the test from the perspective of an external user of the system, forces you really to be able to deploy a version of your software that you can evaluate. So now you've got to think about automating the deployment, and you've got to think about writing a simple mechanism that allows you to write these higher level tests, testing through the user interface of the system or APIs to the system, whatever the entry points of your system are. It allows you to think about these things. It's probably going to start you thinking along the lines of infrastructure as code so that you can automate the deployment of your test environment too and make sure that that's repeatable and reliable. Deploying to production will even a fake version of production, a overly simple best guess of what your eventual production system will look like, will force you to think about those issues. And thinking about these issues for this first initial story means that all of these things are the simplest that they're ever going to be. And so that's going to put you into a position where you have a walking skeleton of your deployment pipeline, hosting the walking skeleton of your application and allowing you to develop and evolve both as your understanding and knowledge grows as you progress with the development of the system. This first story will be too slow to develop. It will take you a long time because of all of this extra work. So I would focus the whole team's efforts on only that story initially. And take as long as it takes. It shouldn't be more than a couple of weeks, hopefully, but but do whatever it takes to get that story up and running and deployable, even though the environment that you're deploying to is a fake version of production. It's going to take a lot of extra work, but this is no problem. This puts you in a fantastic place for future development. And what you will find is after this first story, development will start to accelerate and will go more and more quickly as your infrastructure and your support tooling evolves around your system. The deployment pipeline is an important idea that helps us to organize our development activities more effectively. This bare bones example pipeline is the easiest and most effective way to start. This is even the easiest and most effective way to start if you've got a pre-existing body of software. It also gives you a very high degree of confidence that your changes are ready and safe to put into production when you are ready to do that. And working so that your software is always in a position to be deployable into production, even from this first story, is the most effective way that I know to get going. Thank you very much for watching.